Hello and welcome back. So today we're going to actually update the firmware on the YZXStudio USB Power Monitors. It's not really as hard as you may think. You can actually purchase the programmer from Franky.com. It is available through his site, and Franky.com will take you to an eBay link. And this is the ST-Link version 2 programmer here. And it's clearly marked as far as what pins are what. That makes it really simple. All you need is a ST firmware software to install on whatever platform you choose to run on your computer. And you're pretty much good to go. Now the programmer, when you order it from Franky, it actually comes with 4 very fine pogo pins, as well as a cable. He provides a cable ready to go for you too. Now I've already chosen to use a different cable because I already have one set up here, and just different colors, no big deal. It's actually the same cable he provided. It's the same cable I have right now. Let's take a look at these pogo programmers. These little gold pogo pins. These are actually very interesting, very useful too. I like them. They're very sharp, but you'll notice in one direction it is spring loaded, and the spring helps keep the tension against the programming pads that are located on the PCB board to do the firmware upgrade. So this should make the job a lot easier. I almost just pierced my own finger by doing this, so we're going to put that down. The layout for it is very simple. If you look close enough, all you have to do is pull off the 4 Phillips screws on the opposite side of where your OLED or LCD is. You pull out these 4 Phillips screws. This shielded plate just simply lifts off, and in here you will notice there are, let me zoom in a little bit, a little square and then 3 round contacts. So you got your square, your I/O, your clock, and your 3.3 volt power rail. So all we have to do is simply match up the ground, I/O, clock, and 3.3 volts with this cable, and use the pogo pins to keep contact on the PCB board. Let's go ahead and set this up here so we have our reference. So what I've gone ahead and done here to make this a lot more stable, I've done this with other programmers in the past. I've even gone as far as super gluing these together actually, and I chose to use a bright yellow small wire zip tie, and there's divots. You can see where the metal contacts are. Right there, you see a little metal contact there. So I face one metal contact out on this side, one faces out on this side, and 2 just faces in the middle. None of them face each other. You don't want to short any of these out. But by turning the ones on the outside out, it causes a little divot, so it has a place for the wire tie to hold tightly. So I take the wire tie, I wrap it around, I even them up as much as I can. So while it's still on there, I may even take a pair of pliers while the wire tie is still wrapped around those pins and just give it a turn like this, and that will get 1 or 2 more clicks out of it, and that's enough. Any more than that, you may actually break the wire tie. And then once you have it all flushed up, you trim your wire tie off and you're good to go on this side. Now I chose black as one of the colors in my cable, so I know which one is my ground. That's my starting point. So let's look at the ground here. Pretty much 3 of these will go in a row without a problem. We got the ground, the I/O, the clock, and the 3.3. So if you look at the programmer is actually nicely labeled. We want the ground, which is pin 6, the I/O pin 4, the clock pin 2, and 3.3, which is either pin 7 or 8. So those are the ones we want. Now, how do we tell which pin is what? On the programmer, you see this little triangle here on one side. It's only going to be on one side. It's not going to be over here. Right there indicates pin 1. So pin 1 is this pin in the far top right where that little triangle is. So pin 1 is our reset. So we want the opposite of pin 1 for our clock. So we can use that as a base to start. Actually, I'm going to use the ground as a base to start because I have a black cable for ground, and we can easily determine which one ground is. So now we know pin 1 is on the top row, and the 3 pins we want are 2, 4, and 6. 6 is ground. So we're dealing with the bottom row. So I'm going to insert this on the bottom middle pin, which is our ground. And the next one was going to be the I/O, which is pin 4, just to make sure. The next one in row next to my black is my white, so we want to make the white the I/O. So you're working to the right towards pin 1 again, but on the bottom row. The next one's going to be your clock, and that would be my gray cable for the next one in line. So these 3 pretty much go right in a row. Now I actually did kind of mess up on this. I don't like the pins, these metal contacts, facing upwards. I'm going to turn them around and face them downwards, so that way they don't accidentally short against the upper row of pins. So we got our ground, our I/O, our clock with the pin facing down. There you go. And then we have to provide our 3.3 volts. So this is going to be the one wire that will stretch over and go to the left of the ground, which is our 3.3 volt. And again, make sure that metal contact's facing down. There you go. Now we have this side done. Now we just need to set our pogo pins in place. And the pogo pins, remember, we want the springy section, the thinner part of the pin, that's going to be going towards the board. So I'm going to use a pair of tweezers to insert one pin into each cable here. So once you get all of them in there, try to realign your black cases again. Make sure the pins are all facing the same direction, nice and straight. Try to adjust the pins so they're equal or about equal. They don't have to be perfect because they are spring pins, so they will compensate a little bit when you give a little bit of pressure on them, but if one is definitely way too far down, try to bring it back up a little bit. So now we have our 4 pins ready to go, and they're all spring tension, so all 4 of them will go in and out. And remember, our square is our ground, so we're starting with the square, in this case on the left. So the black wire is my ground, and that's the one that I want to hold in place right here. So I lined up all the pins on the pads and then pushed down to give it that pressure. So this way all these pointy pogo pins literally stab the solder pads And as long as I sit here and hold this down with the pressure and use my other hand to click a button on the mouse, the firmware upgrade should be done. Let's go ahead and change camera angles around. So I've already installed an STI programming software, and the version I'm doing today is going to be the USB 3.0. There's multiple different versions basically, but if you buy your power monitor from Franky, he will send you the firmware for the unit that you purchased at request. You'll never have to worry about not being able to update the unit if you want to. That's definitely another benefit of purchasing it from Franky Tong. Red OLED USB 3.0 inside here. Here's your hex file, standard hex firmware. All we have to do is find the application that I installed. Whoops, actually it was listed here. Here we go. SMT32 ST-Link utility. Let's go ahead and launch the utility. And the utility is up. Settings. Let me click refresh. It says old ST-Link firmware, ST-Link already used. There it is. There's the current ST-Link. Over here where it said firmware version, it said update required. What I did is I went to ST-Link firmware update. You will tell it to device connect, and it will say it's not in DFU mode. DFU mode requires a restart. You unplug it, plug it back in, and quickly click OK and hit device connect again. Here it will tell you the current firmware version and ask you if you want to update the firmware of the programmer. This will update the programmer. We're not updating the YZXStudio yet. We're just updating the ST programmer. Upgrade is successful. Perfect. So now that that's updated, we have to restart it to get it out of DFU mode. Plug it back in again. Close this. I was now able to go into connect. Well, not connect, settings, sorry. Like some of this was completely grayed out. I wasn't able to change any of this, and this is firmware version. It doesn't say update required anymore. So that's exactly where I want to be. Now, let's go ahead and drop our pins onto power monitor. Click OK. No ELF loader found for this operation. That's fine. It did pick up the device. Connection mode normal, frequency 1.8 megahertz, connected SWD. So that's all good. That's stuff I definitely do want to see. It's late. Let's just go ahead and drop the firmware and see if we can do a program and verify. Verify after programming, I prefer. Restart after programming. So this is where you have to hold these pins very steady. If you lose connection, you could break this. So that was it. Done. So apparently updating the ST programmer was the fix. It took 12 seconds, 12 and a half seconds, 12 seconds and 562 microseconds, milliseconds, sorry. So if you can hold your hand steady for 12 seconds, then you can update. Let's go ahead and redirect the camera back down now. As a quick test run, before I go screwing the board back on and everything, I'm just going to plug it in and give it power and flip through the menu to confirm what firmware is actually loaded on here. Now, of course, anytime you're handling anything like this or circuit board, as I mentioned, you need to make sure you're properly grounded, statically safe. I know right now my lab's a little cold, so you're not seeing this, but the whole time it is there. I am connected. I just keep it off camera. Don't think I'm a hypocrite. And the reason for this firmware update today is this little Bluetooth module. We're going to be soldering 3 connections onto this little Bluetooth module so we can actually do remote logging from the ZYX USB Power Monitors. So I'm going to be very careful while I'm doing this because the board is open at this point. We're running firmware version 2.7, which should be the same version that I'm currently running over on this LCD that Franky sent to me, because the LCD was purchased from Franky. It came loaded with the latest firmware when I bought it from him. The other vendor didn't update the firmware. You can see it says 2.7 here. Now there was a slight bug in 2.7, so 2.7 actually needs updated to 2.8. We're going to be doing this next to go to version 2.8. Now that we know we have 2.7 on here, that's what we wanted. Perfect, done. We're not going to install the Bluetooth modules yet. We're going to go ahead and screw this one back together. Okay, so set that aside. Let's go ahead and do this one more time. Now the program contacts this time are actually kind of accessible from here. They're right on the edge. They didn't put them in the middle this time. Technically, if I wanted to, I could hit it like this. Now the problem is I'm not going to recommend doing that as far as hitting those 4 contacts, because this is a shielded PCB, so there is a fine layer of metal running through this PCB, and you're actually pushing up against the PCB with those 4 pins. You will cause those 4 pins to short out, which could cause a ton of damage. And I know my hand is not steady enough to keep contact on those 4 pins and keep it away from the PCB board at the same time. It's easier to keep these pins, the spring-loaded pins, pressed downwards, just straight down, than any other angle. At least for me. Might be a little different for you. Julian did a video slightly different to mine, where he actually set up a glass, and he soldered the pins and the connections on a PCB test board and kind of went that direction to get everything updated. The square has a nice hole in it, so that's easy to get that one. That's very nice actually. Okay, I'm confident on these 4 pins. I don't see a problem here. Let's go ahead and plug the programmer back in. I'm not going to make you watch the computer this time. In fact, the ground, because it does have a hole in that square, the pin went straight through the hole. Because you want that on the pad, not through the hole. So we're plugged in. I'm going to select the folder, the correct folder for this one, and drop that over. Target, connect. It has connected. It's in low power mode, 1.8 megahertz, normal connection mode. Great. So target, program and verify. Verify after programming, restart after programming, and hit start. Flashing memory programming now. Hold your hand steady for about 12 seconds. Do not sneeze, laugh, joke. 12.5 seconds exactly. Verification okay. That's it. Unplug your programmer so you don't short your pins out in your programmer. Give this some power and hold your button in while you start it up so we can double check that it took the firmware update. And it now says version 2.8. So that's it. We're done. I'm going to put this one back together and go get some rest. Tomorrow, hopefully, I'll be able to get the video out there showing this little Bluetooth module installed inside these. I'm going to solder these into place, and we should be able to plug in and do some remote monitoring sitting downstairs, as long as you're within that 30 to 60 feet of distance. And I have a couple different loggers that I've downloaded and installed for Apple devices. I haven't tried them yet because, well, I need to solder one up to actually work. One of them actually does a timestamp every time a piece of data is received, which would be a really nice feature because these don't have a built-in clock. This way it would be reliant upon the time of your device, your iPad, your iPhone, your iPod Touch, whatever it may be, and it may actually stamp every time the voltage, amperage, current, whatever you have it set to for logging comes across. You can just let it collect information, and then you can save the file and then import that into an Excel file, make a nice pretty graph or something later, or open Office, or your the word processor of your choice for that fact, and you'll actually have a timestamp correlation to go along with it. That is, of course, if your device is set for the right time, which if it's your iPhone, it syncs NTP through the cell phone towers with the National Time Database. You should be set to the right time at that point. So we successfully upgraded the OLED to 2.7, and we successfully upgraded the LCD to 2.8. And that's how you update USB power monitors. Steady hand, 12 seconds. Make sure your wiring's correct. Make sure your pins are straight and have contact, and make sure you're on those 4 pads. Click a button, 12 seconds is all you need, and then pull it off. If you can't hold your hand steady for 12 seconds, and the reason I'm doing this tonight is because I'm actually having a good night. Usually I cannot hold my hand steady for 1 second due to tremors and a muscular disease, but if you can't hold your hand steady for 12 seconds, then definitely recommend coming up with some sort of contraption. Go ahead and look at Julian's video and how he did it. Build something to make it easier to be able to keep those 4 pins compressed and on the pads where they belong. Make sure those pins are straight when you put them on the pads and that they have contact on the pads, and you should be good. 12 seconds, click the button, firmware updated, and done. First thing you definitely want to make sure is that you have contact and it says you actually can connect to the host, the programming target. And if you can't connect to the programming target, you may actually want to pull up the ST-Link menu drop down like I mentioned, like I showed earlier. Your programmer, your ST programmer may need updated, and it will tell you that it needs to be in DFU mode, which requires you to unplug it and plug it back in, click OK, refresh, OK, update, and then it will update it. After it's done updating, you unplug it again, wait a second, plug it back in, then you should be able to connect to your power monitor and update them. Thanks for watching. If you liked this video and you enjoyed it, please go ahead and give it a thumbs up. If you haven't already, please subscribe. so you can see more videos like this in the future. Remember, the next one coming up will be remote power logging and how to install a Bluetooth monitor in both of these. I have a Bluetooth monitor for both of them. You've already seen the one that's in the PCB board mount holder here. There's another one right here. So we're going to do two of them. And we're going to get them both logging remotely. One to one iPhone, one to an iPad, one to another iPhone. I don't know, an old iPod Touch I got laying around somewhere, if it runs the software I found. And we'll see which is the best software for it. Alright. Well, again, I hope you enjoyed the video. If you have any comments or suggestions for future videos, as a matter of fact, or something that you may have seen around the lab with my camera floating around, or maybe a future project or something, feel free to leave a comment. I'd take everything in consideration. Thanks for watching.